welcome to our pre-calculus lesson 14. This is for our quiz 2 revision. So as you know, our quiz 2 is coming up, so this is entirely dedicated for that quiz. So the whole thing is just for the revision for this quiz 2. Okay. And so far we have finished this thing for our quiz 2. These are the syllabus also for our quiz 2, 2.1, 2.2, 2.3 and 2.4. And this is the section names: functions, graph of a function, properties of functions, and and library of functions, piecewise defined, etc. So these are the name of our sections. So our first item is library of functions. So for example, this function, this is a graph of some function. What is the name of this function? Or what is the equation for this function? So this one is actually x cube root of x function. This is cube root of x function. That's how we say that y equal to x cube. And this function is odd function because we have our reflection is about origin. So origin reflection means our odd function. And this one is y equal to square root of x function. This one is x square function. This one is modulus of x function. Y equal to minus x function. This is y equal to 1 over x function. Now say for example how this question may come in the exam. So one way is, suppose we give some name. Suppose this is a or this is x y z. Suppose this is x y z u v w, some alphabet u v w. So let's say we are saying which of this function here is y equal to x square function. Suppose which of this function here is y equal to x square function, which of the graph is y equal to x square function, then you have to say this one, oh, z number graph is, so your answer will be z number or z, whichever you say. So this is the answer for the x square function. And is this function is even or odd function? So answer is, oh, this function has y-axis reflection, so this must be even function. This is even function. So this is even function this way. So let's say the graph is given, then you have to say that say the name of the function, or the name is given, then you must be able to find out the function quickly. Okay, this should be the function. So this kind of problem. This one is y equal to x. So if we say which one is y equal to minus x, y equal to minus x function, then you will say y equal to minus x is v. V is the y equal to minus x function, and this is odd function because we have origin symmetry here. This is odd function, y equal to minus x. Or if we write fx equals to minus x, fx equals to minus x. So basically the same thing. Fx equals to minus x and y equal to minus x, same thing. You should by now you should know that y equal to and fx equals to, they mean the same thing. Answer is same. This one is the answer. Y equal to minus x graph is this one. And how do we get this graph? Suppose you can ask very basic questions are, how do we know that this one is y equal to root x graph, or y equal to 1 by x graph is this one? How do we know that? And for that, basically the process is you have to draw that. Now that we have drawn a lot of graphs, so now we know how to draw this kind of graph. Any graph, like put some value of x here, then draw it, then you will have this graph. But in pre-calculus, when you go for like more advanced lessons, then basically you will not have time for drawing all the graph. Do you understand? If we say that, hey, y equal to x line, draw y equal to x line here in this graph, y equal to x line, so we give you a graph, we say that y equal to x line, draw the graph, you should automatically know that y equal to x line, x graph is some line going through the origin and dividing first quadrant and third quadrant into equal half. Just a straight line which divides this box into half and this box into half also. And if you try to draw it, you will exactly get this exact graph. You will definitely get this exact graph. like that. Or if we say that y equal to x square graph, y equal to x square graph is which one? You should say that, oh, y equal to x square graph shape is this one. So which is this one actually? I mean, you should be somewhat. You should be some kind of master of this basic graph. We are not saying that. Of course, we are not saying that all the graphs you should know. That's not possible. But these are the very basic and very important graphs. So that's why we need to have them in our visual memory kind of. These are the graph. These are the graph. These are the graph. Then you will understand the topics better. You will understand the questions and the analysis better if you understand automatically these are the graphs of this function. Then it will be better. So anyway, these are the some basic graphs. We have actually 3 more graphs also in the book. If you go through the books, then you will see that in the library of functions there are like 9 graphs. So 6 graphs are here. You can review the other 3 also. Range, increasing, decreasing, maxima and minima. Suppose some graph is given. What is the range of this graph? What is the range of this graph? You know, the range is the y value, maximum y value to the minimum y value. And in this graph, look at this. What is our maximum y value? Is this our maximum y value, or this is our maximum? Maximum means highest, or top y value to the lowest y value. You will notice that this point is the top point here. That means it is 1. Y value is 1, and this is going to the negative side. That means negative infinity. So that means negative infinity up to plus 1. So this is the range, negative infinity to plus 1. You can write this way or this way, both means the same thing. And this negative, this plus 1 is included. As you can see, the point is dark. And from where to where the graph is increasing. As you know, for increasing functions, you will start counting from left to right. Then you will hit this point first. Then you can see that this part of the graph is actually increasing. This part of the graph is increasing from up until here, this point. Then from here to this point, it is actually decreasing. Then from this point to this point, it is increasing. Then from this point to infinity, this is actually decreasing. This is decreasing. The main clue here is you should start from left side. Then everything will start making sense. Okay. Then you will not make mistake. So increasing is 2 part. There is 2 boxes. One is this one. There is 2 part where we have the increasing part, and you know, for the increasing, decreasing, and constant, only we write the x part. Only we write the x part of the points. So that means minus infinity to minus 4. It is increasing. That's why we were saying here from minus infinity to minus 4. So this one, minus infinity to minus 4, and then 1. This is 1 to 3. So 1 2 3. From minus 1 to 3. This is also increasing. You can write in set notation also. Set notation, if you write set notation, this is how you can write the set notation. X is less than minus 4. That means from this point to minus infinity, that is x is less than minus 4. And this is from 1 up until plus 3. Minus 1 up to plus 3. And minus 1 and plus 3, none of them is included. So none of them are included. That's why there is no equal sign here. No equal sign here. And then decreasing is from minus 4 to minus 1, and then plus 3 to plus infinity. So plus 3 to plus infinity, and minus 4 to minus 1. Where is local maximum? So you see in this graph, this point will have some local maximum, and this point will have some local maximum. And the question is where? Where is it? So one is at minus 4, one is at 3. So if we say that where is local maximum, local minimum, where is it? Then you will say the x value. And if you say that what is the value at minus 4, then you will say that at minus 4 value is 1, and at 3 value is minus 1. at 3 value is minus 1. These are the value, and these are, suppose the question is where is local maximum, then answer is these two. If the question is where is local maximum, so you will say minus 4 at minus 4 and 3. What is the value at minus 4? Value is 1 at minus 4 and value is minus 1 at plus 3. So this is the value. This is the value of the maximum, and this is the place where we will have this local maximum. So this part is finding from the graph range, increasing, decreasing, maximum, minimum, etc. So these are the, I should give a comma here. Anyway, so then we have this part, domain range of function. First of all, you have to find out, is this a function or not? Suppose this one is given, is this a function or not a function? You will notice that this is minus 2 and minus 1, 0, 1, 2. All the x values are distinct, they are different. They are completely different. So this must be a function. And now no matter what are the y values, they are different. So it is a function. So this is a definitely function. And the domain are the x value. So this is minus 2, minus 1, 0, 1 and 2. They are the, let's give second bracket here. They are the domain, and range are the this value. Range is the y value. So they are the range. So the domain, first of all, so the answer of this question is, first of all, question number A, is it a function? Answer is yes, it is a function. What are the domain? Domain are the this and range are the this. B number question, is it a function? Actually, you will see that if we draw a vertical line, our vertical line crosses the graph at two different points. So this is not a function. So this is not a function. If it is not a function, we do not have to find out domain and range. We will say that this is not a function. Okay. Now this one is 5 minus root of x. 5 minus root of x. Is it a function? You know that the square root function is somewhat like this. Normally square root function, x equal to y equal to square root of x, y equal to square root of x function. So basically, square root function is a square root graph is a function. Square root graph is a function. And when this kind of thing is given, you know how to find out the domain from this thing. 5 minus x. This value has to be greater than or equal to 0, right? This is how we can find out. This is how we can find out this kind of thing. So minus x is greater or equals to minus 5. Then we have x. Now you know that if we multiply both sides of an inequality by a negative sign, then what happens here is our sign actually changes. So it will become x is less or equal to plus 5. X is less or equal to plus 5. So this is the, that's why this is the domain of this function. And you can give second bracket if you want to write it in set notation. In fact, complete set notation is x such that x is less or equals to this. So that is the domain of this function. And range of this function is y is greater or equal to 0, because actually in this square root function, this one is not this graph. Actually, this is this function. The value of y actually starts from 0, then goes to the positive infinity. Then goes for the positive infinity. Y equal to 5 is square root of minus x. As you can see here, x is less or equal to 5. X is less or equal to 5 tells us that the graph will go to the left side. Graph will go to the left side. Let me show you that. We can actually draw this here. Oh, we have one square function. So 5 minus x was that. This is 5 minus x, square root of 5 minus x. I'll clean it up, don't worry. Square root of 5 minus 6. It will go to the left side, and five minus x. So this is the graph. It is going to the left side, because as you can see that if we put the value, then basically it will come. Also in our domain we have seen that x is less than or equal to 5, and you can see that less than or equal to 5 is here, and this is the thing. And you can say, sir, in the graph, in the exam, what we will do is, do we have time to draw and check it here? That's not the thing, but if you go through some of the square root function, then you will have the idea that the graph actually have this kind of it starts from 0 and goes for the positive infinity for the range, part. Suppose if you write 2 minus x, 3 minus x, x plus 2, x plus 3, x plus 4, x plus 5 root within the root, all of them will have same range. Suppose if you write y equal to root x, y equal to root x plus 2, root x plus 2, y equal to root x plus 3, whatever you write, I mean all of them will have their range will be y is greater or equal to 0. Suppose if you write y equals to x minus 8, basically the point moves, this value moves here and here, and this shape is in this direction. This plus 2 means now the graph will start at minus 2. So the shape remains the same. This is what I wanted to mean. Shape remains the same. If you do experiment with couple of square root of x graph, then square root of x plus 2, square root of x minus 2, 2 minus square root 2 minus x, 3 minus x within the square root. The shape is like they just flip for the negative x, and for the positive x this one, for the positive x this one, for the negative x this one, and for these numbers the graph actually moves on the x-axis here to here, like that. But this point remains at the same position. So our range is from 0 to the positive infinity. That is the point. From 0 to the positive infinity, that is the range. Range is always there. So this is why y is greater or equal to is the range, y is greater or equal to 0, that is the range. Then we have this part. This part of the graph is, this part of this question is combining the functions. So you will have like there is two functions here. There are two functions here. One is this one. Suppose one is this one and this one. So if we say that f of f plus g of x. So how do we do that? That means we have to do this 3x plus 4 plus twice x minus 3. That means our answer will be 3x plus twice x equals to 5x. Then 4 minus 3 equal to 1. That means plus 1. So if we add them, f plus g of x, our answer is this. 3 plus 2 equal to 5, 4 minus 3 equal to 1. Now there is another question like 3. That means f plus g of 3. It means now put here 3 instead of this x, put 3. So if we put 3 here, so it will become 5 into 3 plus 1. Answer is 5 into 3 equal to 16. 16 plus 1 equals to 15. 15 plus 1 equals to 16. So you can see that this A number question and E number question is interrelated. They are interrelated to each other. This one is just f minus g. That means this function minus this function. This is f into g of x. That means this function into this function. D is f divided by g. So that basically f divided by g means twice x plus 4 divided by twice x minus 3, and that's the end. Actually that's the end, because we cannot do anything else here. we cannot do anything else here. So since we cannot do anything else here, so this is the answer of this D number question. Like this, then f divided by g of 1, that means we have to put here 1 and 1, then do some algebraic simplification, whatever the answer comes. For 65 number also similar kind of operation we have to do, similar kind of thing. First of all, suppose if it is plus, then we have to do add them. If it is multiply, we have to multiply them and write the final thing in our solution. Suppose 65 number, if I show the multiplication part, then it will be x minus 1 into 2x square. So now you multiply them, it will become x into x, that means x cubed, so it will become 2x cubed minus 1 into 2x square means 2x square. So you can write this. That's it. So that's the multiplication. And now if you want to put 2, because this multiplication c and g is interrelated, so if we want to put, see, f into g, then x, then 2, that means instead of x we have to put 2 now. So if we put 2, we will get the solution of g number. If we put 2 here, 2 square minus 2, oh, this is 2 cube, then 2 square. So 2 square means, let's do this part first, this part first. So 2 cube means 8 into 2 equals to 16, minus 2 square means 4, into 2 means 8, that means answer is 8. So answer is 8. So this is how we find the value, and this is how we do their algebraic forms. There is 2 math here, one math finished here and another math is here, 2 maths here. So this is how we combine 2 functions. We combine 2 or more functions this way. This is the way, this is the process for combining the functions. Then we have average rate of change and secant line, this kind of question. So if we say that find out the value of f of g of x, let's say g of 1 equal to what? Suppose if we say g of 1 equal to what? G of 1 equals to what? So what you will do? We have to just put here 1 square plus 1. Then 1 square equal to 1 plus 1 equals to 2. This is how we put the value in the given function. Now instead of 1, suppose it is 5 given. What you will do? Instead of 1, 5 given. Just here instead of 1 it will be 5. Now can we change this 1 also? Answer is no, because this one is given in the question directly. So this is 5 square, that means 25 plus 1 equals to 26. So answer is 26. So basically if this number changes, it doesn't change our method or anything in the maths. It just changes the solution, is the final answer. It just changes that. But our process and everything remains the same. This math actually we discussed in our some previous lesson. For this kind of math, what we have to do is, first of all, we put minus 1 in this function. Suppose g of minus 1. So g of minus 1 equals to, if I put minus 1, it becomes plus 1. 1 plus 1 equals to 2. So answer will be 2, and the point is for minus 1 we get 2. And if we put 2 in this function, then g of 2 equals to, so 2 square plus 1, that means 2 square means 4, 4 plus 1 equals to 5. I'm just doing this calculation because this is super small calculation. So this point will be for x value 2, y value 5. For x value 2, y value 5. And how do we know that this is y value? This is y value. How do we know that? Because this is g of x. G of x, f of x, it means y. That means y equal to 5. This means y. This side means y. And this side means y. Now, average rate of change. Average rate of change means slope. So slope is what? Slope equals to y2 minus y1 divided by x2 minus x1. That means 5 minus 2 divided by x2 means 2 minus 1. And you will see that 5 minus 2 equals to 3, and then 2 minus okay, let's give it nicely. So this is 3, then 2 minus plus 1 equal to 3. 3 divided by 3 equals to 1. 3 divided by 3 equals to 1. So this is the answer of a number question. That means average rate of change. Slope is 1. Then b number, we have to find out the equation of the line. Equation of the line containing these 2 points, because they are the same point actually. We are talking about, see, this is -1, this is -1, and this is 2, this is 2, and g of -1, see, g of -1 equals to 2, so this is the 2. So basically this answer g of -1 equals to 2. So g of -1 we have to put here, that means 2 we have to put here. So already we have, my point is, already we have found the points. We do not have to recalculate them, since they are the actual points. Now y minus y1, let's say y1 is 2, equals to m1, x minus x1. X minus x1 means minus plus here now, because there is one another minus here, so minus plus. Then y equals to x plus 1, then this 2 will come to this side, and it will become plus 2. Ultimately we will get x plus 3. So y equal to x plus 3. This is the equation of the second line. And second line means, suppose you have a curve, then second line means the line, this is straight line which cuts the curve at 2 different points. This line name is called the second line, and this is the curve. This curve is this one. This is the equation of the curve, and this is the curve. This g of x, this is the curve, and second line means this is straight line. Second line. Just if you want to have some visual idea of this maths, what does it mean? So this is the visual idea about that. So you can ask, sir, if it is 3-part question, A, B, C, then where is our C number? In basically, A number will be different. This is B, C, and then A number will be, suppose we can say find out f of suppose we can say find out f of 2 equals to what, suppose, or f of 4 equals to what, or f of 10 equals to what. I think you can find it out. Suppose f of 10 equals to what? F of 10 equals to 10 square plus 1, that means 101. 10 square means 100, 10 square means 100, then plus 1 equal to 101. So this kind of math. So you have ABC3 actually. Just if you are super confused, then that's our output, or that's our answer to that question. And then we have some real life problems. This is also actually from the book, Effect of Gravity on Jupiter. In fact, this kind of maths we can create and recreate. Then basically this kind of function will be something different, but the pattern of the math remains the same. So in Jupiter, what happens is, if you drop some rocks from 20 meter, then the equation, because this is the function, then the function becomes this. Now, since our function is given, and then we have to find out h of 1 equal to what, then we will just put the value of 1 here and do some calculation will bring us here. Or h of 1.1 equal to what, then we will put 1.1 here, then do the calculation, answer comes here. That's the thing. And then in the second part, our height is given 15. That means this place now we will put 15, and we will try to find out the value of x, and the solution is given here. So if we put 15 here, 15 minus this 20 equals to -5. That means -5 equals to -13x squared, Then minus cancel out from the both side. Then x equal to square root of plus minus this, and we will take only the positive part, because we are interested about the positive answer here. X is the number of seconds needs to be positive here. In most cases it is positive. What is the value of h of x on the ground? In this case, let me do this part. So we will put, in fact, this B part and C part both is same type of math. For B part it is 15 here, we have to put 15 because 15 is given, and for C part we have to put here 0 because it is said as ground. Ground means height 0. So we have to put 0 here. So 0 equals to 20. Oh, this is also, actually we have it here. Then 0 equals to, okay, let's do it live. Then it may make sense a little bit better. So 0 equal to 20 minus 13x square. 0. Why 0 here? Why 0 here? Because it said that it is ground, on the ground. So that means the rock is now on the ground. That means there is no height now. That's why. Then 20 will go to the other side, which will make it negative. That means minus 20 equals to minus 13x square. This is how we do all the math, or most of the maths actually. The calculation process is more or less the same. So minus minus cancel out from the both side, and then we have 20 divided by this 13, then x squared. That means x squared equals to 20 divided by 13. And if you want to remove this square from this side, we have to give the square root here. And for the square root, we always have to give the plus minus. When a square comes to the other side, then we give the square root. For that square root, since we are exchanging this square from the other side, we have to give the plus minus here. But again, there is another logic here. Since this x is a number, x is a second here. How many seconds it took to come to the ground for that rock? Since it is a positive, it will be some positive answer. So we can ignore this negative. My point here is, don't get confused. You can say, sir, sometimes you give plus minus, sometimes you do not give. We do not understand. Actually, when this square will transfer or come to the other side as a square root, then always there is plus minus. But due to a real life situation here, we are ignoring this minus sign. Don't think that there is no minus sign. There is that minus sign, but we are ignoring it here because the number of second will be positive. That's why. So now square root of plus minus, you just use some calculator and just calculator to find out. Okay, let me try to find it out how to do. 20 divided by 30, 20 divided by 13. So you will get this answer. Remember, let me fix it. Remember, see, I have given a bracket here. See, I have given a bracket here. You have to give a bracket. Square root, then bracket, then 20 divided by 13. 20 divided by 13. Or else answer will come wrong. So answer came 1.24. So answer is 1.24. This is the answer. Okay. So this is how we can do this kind of calculation. And we have done the math here. See, 1.24 is here also. 1.24 here also. Yeah. So there is the 1.2. Same calculation. If you do it, answer will come same. Then we have some more graphs here. Basically, we thought that this kind of graphs, since they are related to real life, you may get some interest in this kind of graphs. You may get some interest in these kinds of graphs. Suppose this kind of graph. What can this graph mean? What can this graph mean? What type of idea from our actual life or from our real life? What kind of we have one life and that is actual life. So that's not like, it's not like our fake life we have and actual life we have, not like that. Anyway, so in our actual life, from our real life, we have this kind of situation. We have this graph, and these are real actually. Say this will be the graph of human height. Suppose we are growing. All of a sudden, you will see that when we pass our teenage and then we come to our some young age, then we do not grow anymore in terms of height. We do not grow anymore in terms of intellect. We grow all in our whole life, but height stops increasing. So basically, our height increases. Then at some point, our height do not increase anymore. It becomes fixed. So this is our time and height of some human being. Now you can say, sir, is it true only for human being? Isn't it true for, let's say, chicken? Answer is, yeah, that's correct. This is true for chicken also. You can say, okay, for chicken it is correct, but I love dogs. So is it true for dogs? That's correct. This is true for dogs also. Because you think about that. For dog, what happens? Dog, the height of the dog increases. Suppose 1 year old dog, 2 years old dog, 3 years old dog, 4 years old dog. At some point, when they come to some their age limit, then they just pass the time. They do not, their height do not grows approximately. Let's say approximately. Very, this becomes like straight. Then child on some swing. We have the question here. Suppose the number question, cost of a building house as a function of its square footage. This is this graph. This kind of. So these are the question. Actual questions are here. Just we are now discussing the graphs. You will be able to find out which graph is which question. So this actually is the time and height of a child on some swing. Swing is something like, if we have, let's say I have some question here. Swing is something like, sorry. Suppose some child sits here, and then it goes like this, or you can do this. This is swing. This is swing. This is some swing. You know. So you see this thing actually one time goes up, then come to here, then one time goes up again, then comes down, then goes up in the other side, then again goes up, then again goes up. So this is the swing. And the graph will be somewhat, you see, the graph will be going up, going down, going up, going down. We can actually explain the more vivid, more from other point of view, and considering all the values and other things also, but that's not necessary in this case. Just to give you some idea, it will keep changing since the height of the child here is changing. Always think about what is changing here, time and height. So basically height will be like going up, going down, going up, going down. So that's the point here. And here, see, there is no time here in this question. In this question is square footage here, then y-axis is cost. So this axis is square footage. It means, and this is cost. It means if you want to buy some big house, you have to pay more, which is big house is like big square footage, then you have to pay more. Then if you buy some small house, which is here square footage, very small square footage, then you have to pay less. And this is matching, this is matching, because if you try to buy some bigger and bigger and bigger house, you have to pay more and more and more. You have to pay more and more. Of course, we are talking about some particular place. You can say, sir, in my village, the price of the land is very small, very low, but in the city, price is very high. So what will be the graph then? This is not, we are considering, let's say, in the village, 5 pieces of land. One is small, one is big. What will be the cost? So if for the big land, cost will be bigger. For the small land, price will be smaller. Price amount will be less. Or if you come to some city, and then in the city, 2 different lands, one land is small, another land is bigger, so bigger land will cost bigger amount. Or you talk about the flat apartment in the same place, same city, then the bigger apartment, bigger flats will have some bigger price. Of course, still you can come up with some more and more. Okay, you can say, sir, in my locality, how the price is much higher, which can be true relatively. But this is some ideal situation. Normally, if the square footage, you want a bigger house, you have to pay more, no matter where you go. A dropped egg, time versus height. So you go to some height, dropped egg, see about some egg, 300 feet from some high building, you just drop it. So initially the height was too much, then height decreases, and at some point it touches the ground. Height becomes zero. So basically this is the graph of some dropped eggs, dropped stone, dropped marble, dropped some table tennis ball. This kind of graph. Then some hamburgers, some burgers. If you go to the burger shop and suppose the burger shop, the price of the burger is not too much, then you have suppose that then the demand is higher. Suppose this side is, this x-axis is price, this side is demand. So price is less here, this is 1, suppose this is 2, this kind of value. And when the price is 1, then see our demand is very high, this is our demand at that time, suppose it is 10, let's say. Then when price goes very high, suppose here, which is, let's say 8, 10 something, then our demand becomes very low. Let's say 2 here, let's say 8 here, some bigger value we are giving. It means what? It means if you go to some shop, suppose they keep the same quality and all of a sudden they increase the price of their product. Then what you do? We say, okay, these people are increase the amount of the price for their product. So what I will do is, since I need it, then I will buy less, so that I don't have to give spend more monies on this same product which I used to buy with much less cost. So this is what happens always. Whatever you buy, if the price unnecessarily goes up, then we buy the product less and less and less amount. This graph is actually telling us that if the price goes up, then our demand actually decreases. Demand decreases means psychologically we convince ourselves that we will not buy it more. So this happens. So you can, again, I know since this is especially quiz preparation exam, so you can say, sir, what type of question may come? You were saying question, you were saying giving the answers like that. So say we will not give you this thing in the exam, kind of that. Okay, suppose if this kind of graph comes, or if similar graph comes, then this will be the situation. Then you have to match, like we can say, like say this one, the demand of a big Macs, this burger question, demand and price. We can say that, okay, which graph here matches demand and price? So say we give here graph M N O P Q. Which graph here matches with this concept of demand and the price? So you have to say graph Q. This graph is matching with this D number, or with this demand and price related thing. This Q number matches. So this is the thing. And this is not only, by the way, this is not only burger related. This is chart related thing, books related thing. For the same books, if they unnecessarily increase the price, we go and we like, okay, we will not buy the book, or let's buy one copy of the book and photocopy other things. Because we human being always try to adapt to it. Some benefitful situation. In most cases, they always find a way out to get the maximum benefit from minimum input. This is human nature. This is how human being evolved. So we have to agree on that. Anyway, so this is the situation that can appear, or this is how things goes. Okay, and these graphs are actually really interesting in terms of our real life thing, because now you see these graphs actually can represent our real life situation. Then we have some more practice thing for you all. You can practice, suppose library of function. You can study page number 81 to 84, domain range, increasing, decreasing, maximum, minima. You should go to the page number 77 from our PDF book, and 21 to 32 number. Then this question, you can see, actually you will say that, sir, there are many things, but you see this is 57 number page, 57 number page, 57 number page. So basically you see there is some relationship also. So you feel free to practice these maths for really good score in your exam. You should, of course, you will not have to do all the maths. Suppose 21 number to 32 number, no need to do all the maths. Do some maths from here and try to understand the concept. Do not memorize the answer. Just try to understand the concept. that okay, this is if increasing decreasing comes, I will do this and that. These are the things that get the idea. You get the idea about this. So second line 78 number page and question number 63 to 68. So as you can see, there are 5 maths here. You can do 2-3 maths. Whichever you think like difficult, you can do that kind of maths from here. It should be fine. Like these are the things that you should practice for your quiz. And that's all from our side. Thank you all. Thank you very much, and best of luck for the quiz. Okay, best of luck. Bye bye. See ya. In the class also, by the way, in the class also we will review this. So if you have more questions, please feel free to ask your questions during our classes. Thank you very much. Bye bye.